Okay, the first thing we're going to do when we do limit algebraically is just plug it in. Okay, if we get a number, we're done. If we get 0, 0, we're going to do algebraic manipulations. If we get some number divided by 0, we're going to think, it's going to infinity. Is it going to positive infinity, or is it going to negative infinity, or does it depend on which side we're coming from? So in this case, we plug in 3, and we get 9 minus 6 over 3 plus 1, 15 over 4, done. That's the limit. The function was continuous in every value except for -1. So of course at 3, the limit equals what was there. Remember, if f is, I'm just write it this way, f is continuous at x equals c, if and only if what you aim for is what you get. The only place we have issues with continuity here is the vertical asymptote x is -1. It's continuous everywhere else. So the limit at some number is going to be what's there. So we just plug 3 in. We got what's there. 9 minus 6, 3 plus 1. 9 minus 6, of course, isn't 15. I added instead of subtracting. I apologize. Thank you for speaking up eventually. So I looked at bewilderment on Michael's eyes, and I looked at it carefully. I knew something was wrong. Alois, you're so good. Do number 7.
Okay. The limit of x approaches 1 from the
minus sign?
No, it's the plus.
From the right.
Okay. Of x to the 4th minus 1 all over x minus 1.
Okay. Now, here's the situation. Here's a situation where we have an issue at 1. When we plug in 1, the top becomes 0, the bottom becomes 0. So the answer could be anything. Could be literally any real number. Could be does not exist. It could be positive infinity. Could be negative infinity. Okay. So we're going to have to do something. And I'm hoping that you recognize how to factor x to the 4th minus 1. Do you recognize it? Ding, 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 ding. Thinking it's a binomial. It factors if it's something squared minus something squared. It's x squared squared minus 1 squared. So it's x squared plus 1, x squared minus 1. But then, Alois, what are you thinking when you see x squared minus 1? Yes, it's true. So if we plug in now, we're getting 0 to 0 again, so we need to do something more. Does anything factor? Anything else factor? Does x squared plus 1 factor? Sum of squares factor? No. X minus 1 is a linear term. It doesn't factor. Done. What about x squared minus 1?
X plus 1, x minus 1?
Yes. Now, I should back up. We've had some problems where we factored this into root x plus 1, root x minus 1. If I had some root x's somewhere, I might consider that. But there aren't any. So I agree now. We have the x squared plus 1, x plus 1, x minus 1. The bottom x minus 1, now it cancels. Now notice, we're approaching 1. When we're at 1, it's not in the domain of this function. But when we're not at 1, this x minus 1 cancels. And now I can plug in, and I get 1 plus 1 times 1 plus 1, which is 4. The answer to that problem is 4. Now, you guys should not miss any problems on section 1-2, algebraic limits. Absolutely no excuse to miss these. How come? You type it in your calculator and give you the answer. Okay? And you're welcome to do that. But you're not going to have the calculator on the test, so you might want to use it as a verification of what you're doing instead of as the only method. But if you're stuck on one, use the calculator and then ask about it.
How do you make sure that like it's not different coming from the negative side?
Well, if in this case, we don't care what's happening from the negative side. They didn't ask.
How do you?
But the fact is, even if this had been plus, minus, or neither, we'd be doing the exact same thing here, because If we're approaching from the right, we're approaching from the left, we're approaching from any side, this is what we have, right? And when x isn't 1, because it's not 1, it's approaching 1, right? It isn't 1, then isn't x minus 1 over x minus 1, aren't those the same numbers, even whether it's positive or negative? And so it cancels, and we still get that number, okay? Now, there are going to be other problems later on where it's going to matter if we're coming from the right or left, and I think I might answer where you're getting later on. I think it's going to show up later on, okay? Day 10, number 9.
The limit of
Speak up, no louder, please.
okay, the limit of x approaches to
The
negative
limit
1
as
and
x approaches,
to negative 1 of x squared plus 6x plus 5 all over x squared minus 3x minus 4.
minus 4. Okay, if we plug in negative 1, the top becomes 1 plus negative 6 plus 5, which is 0, and the bottom becomes 1 plus 3 minus 4, which is 0. So we don't know what the answer is going to be. Okay, we're getting 0, 0. So we need to do some kind of algebraic manipulation, and our first choice is to factor. First choice is to factor. If we're able to factor it, factor it. Okay? And this becomes,
X plus 1 x plus 5
good, I did it the other way around. This one,
x minus 4x plus 1
what happens?
cancel x plus 1
They cancel. And so the negative 1 created a 0 here, but it's a hole. It's a hole in the function. The same factors on top and bottom. It's a hole in the function. So we don't care about what the hole, we care about what's approaching there. So now we plug in negative 1 and we get,
over negative 4 over 5
no, 4 over
negative 5
negative 5. So negative 4/5. 4 over negative 5. That's what you said. All right. Eleven. Matt.
The limit as x approaches negative 1 of 2x squared plus 1 minus 1, all divided by x plus 1.
Some isn't right. 2x plus 1 minus 1.
2x plus x.
Plus x.
2x squared plus x minus 1 all over x plus 1. We plug in negative 1, and on the bottom we get 0. And on the top we get 2 plus negative 1 minus 1. So we're getting 0, 0. So what's going on? Okay, these problems are contrived. They're not going to give you many where you just plug in and get the answer. I mean, it's just no big deal there. The interesting ones are where there's a hole or vertical asymptote. So we have to factor top and bottom, and so all this factoring is being reviewed. The bottom doesn't need to change, but the top, can you factor that, Matt? We have a trinomial, okay? To get the trinomial into two binomials, to get 2x squared, it has to be 2x and x. To get a 1 at the end, it's got to be 1 and 1. So the question is it plus, plus, minus, minus, plus, minus, minus, plus. Okay, that's a minus sign, so they have to be different. So it's either plus, minus, or minus, plus. Which one works?
Plus minus.
Okay, and we'll try that, and we'll see if you did it right. We'll check it. We get 2x squared minus 2x plus 1x is negative x minus 1. That was wrong. So we simply throw the minus sign there, change that to a plus. That's a good way to do the factoring. Put some in, check it. If it's wrong, switch it. Okay? There's nothing wrong with that. You knew it had to be 2x times x to get 2x squared. You knew it had to be 1 and 1 to get to 1. So there it is. Now the other thing is we had an x plus 1 on the bottom. So didn't we expect to get an x plus 1 on top? When we got 0 over 0, we knew we were going to get an x plus 1 on top. So you should have known that you're going to get an x plus 1 on top. Another reason to know is 2x minus 1. Okay? That cancels. Now we plug in negative 1. We have 2 times negative 1 minus 1. Negative 2 minus 1. Negative 3. Negative 3. Okay? 13.
The limit as t approaches 2 of t cubed plus 3t squared minus 12t plus 4 all over t cubed minus 4t.
Okay, we plug in 2, we get 8 plus 12 minus 24 plus 4. That's 0. And the bottom's a little easier, it's 8 minus 8. 0, so we got to be able to factor. The bottom factors pretty easily into a t squared minus 4. So I'm jumping right at it. Wasn't that nice, Billy? I did the easy one. I'm giving you the hard one.
Oh, thank you.
Do you know how to factor the top?
Can you like separate them?
Okay. What do you think? It's
Could you
called
pull-
factoring by grouping.
So could you pull a t squared out of the first part?
That's going to be excellent as long as I can pull something out of the second part, which leaves the same thing. What do we pull out of the second part?
I was gonna say a 4, but that would.
That's almost right. A -4, right?
Oh, okay.
And that gets us a 3t plus 1, and now it's not working.
No.
It's not working. Did we copy the problem out correctly?
Yes, sir.
Okay, so let's try something else. So I have the advantage here, I can erase. So, boy, I might have wished I hadn't done this problem, because it's pretty hard, okay? But if I pull this out, I get a t and I have t squared minus 12. That's not going to work. So I don't see it working by grouping. So I'm going to use the idea that I can't get a t out of there.
Right.
I got to either be able to get a t plus 2 or t minus 2 for this to be a reasonable problem. And in fact, the only thing that makes the bottom 0 is when t is 0, t is -2, or t is 2. So it's got to be one of those, and actually we know it's going to be t is 2. That's the problem, right?
Right.
So, because we're going to 2, so we got to have a t minus 2 on top. So, do you guys remember how I pulled t minus 2 out of this? Do you remember 1, 3, -12, 4, t minus 2, put a 2, 1, multiply and add, multiply and add, multiply and add. It worked, and I'm left with t squared plus 5t minus 2. How cool is that? Maybe got to be on the tougher part of the test, right? That's a lot of work. Maybe that's so hard we get our calculator out, right? Okay, but that's a lot of algebra review. Okay, that's how we did it. Synthetic division. I could have done it polynomial long division. Okay, but covered that in Algebra 2 honors. So yeah, most of you guys have seen that. And so I sure would not have been able to look at that and knew that it factored into a trinomial times a binomial. No way. Okay, but because we got the 0 over 0, and we're going t is 2, that's creating 0 in the bottom, t minus 2. So we had to have a t minus 2 on top. So I divided it by t minus 2. Remember, polynomial long division, x minus c on the outside. And so we're able to get it. These cancel. So now just plug in the 2, get whatever you get. Okay, we've done the hard part. Yes?
Why can't you like multiply by 1 over t cubed all over 1 over t cubed?
Well, that's going to be good if we're going to infinity.
Yeah.
Because if we're going to infinity, all those numbers will turn into 0 then, except for a couple. But here with it 2, all of them are going to get crazy fractions. It's going to be no easier. Okay?
The limit as x approaches 3 from the positive side of x over x minus 3.
Okay, now look at the jump. We've gone from 13 to 15. And it's like the problems are supposed to be getting harder. Well, in the one hand, sure looks a lot easier. But there is a more challenging conceptual issue we have to start dealing with here. Okay, and it gets back to Mac's question early on. Okay, and here's how you do this problem. We plug into 3, we get 3 on top. We don't get 0, we get 0 on the bottom. So the answer is plus infinity or it's negative infinity. It does not exist. I would say, or it does not exist. It's going to be one of these 3 answers. Well, we have to decide which is the appropriate answer. Since we're coming towards 3 from the right, this number's a little bit bigger than 3. So what I like to do is I put a little plus next to the 0, because it's going to be on the positive side of 0. Do you agree? It's not ever going to be 0. It's approaching 0. That's why when we get 0 over 0, see, we never really had 0. We were approaching 0, right? Because we never were plugging in -1. We were approaching plugging in -1. So back here, we're approaching 3 from the right. It's like 3.1, 3.01, 3.001. And so what's the answer, Michael? 3, positive 3 divided by a tiny, tiny positive number. Which of these am I going to get? Positive infinity, negative infinity, or I could get both? Positive infinity. That's how we do it. Okay? 17. Spencer.
Okay. So the limit as x approaches 3 of x all over x minus 3.
So the missing problem, I imagine it's number 16 in the book, is the limit is x approaches 3 from the left of x over x minus 3, which gets us 3 over 0, but slightly negative. Because I'm approaching 3 from the left, it's like 2.9, 2.98, 2.9999, and I'm getting a negative number, and so this is negative infinity. So from the right, Michael's problem, positive infinity. Number 16, if we've done that, negative infinity. So Spencer, what's the answer? Limit x approaches 3 of x over x minus 3.
Does not exist.
Does not exist. And I might have mentioned in one of the classes, we probably should scratch out the equal sign, but I never done that in the past, and it doesn't seem to have been a problem. Okay. All right. Let's do a couple more on this board. Making good progress. 19.
The limit as x approaches 2 from the negative side of x over x squared minus 4.
Okay. Now, what do we get when we just plug it in? On top?
2.
On bottom?
0.
Are we going to get a positive 0 or a negative 0? Think about it being 1.9, 1.98. I'm approaching 2 from the left. Okay? Approaching 2 from the left.
So negative.
So what's the answer?
Negative infinity.
That's how we do it. We're going to have to consider all the factors and decide, is my answer going to be positive, negative, or is it going to depend from which side we're coming? Like 17, it depended. On one side it was positive infinity, one side was negative infinity, so we had to. Now, if we had graphed that, you would have seen, if we had graphed number 15, 16, 17, you would have seen at x is 3, we said from the left it was negative infinity, and the right is positive infinity. You would have seen the graph, and you would have just answered it off of the graph. So that's the other way to do it, is to graph it. Okay. 21. Here.
The limit as y approaches 6 from the positive side of y plus 6 all over y squared minus 36.
So what do we get? Plug it in, what do we get?
Well, you
The
get
top?
12 over 0.
Okay, is it going to be positive 0 or negative 0? Or is it going to depend? It's going to be positive. We have a number a little bit bigger than 6. We square that's a little bigger than 36. So it's going to be positive. What's the answer to this one?
Positive.
Positive infinity. 22, Tyree. 22.
The limit as y approaches 6 from the negative side, y plus 6 over y squared minus 6.
Top becomes, bottom becomes 0 from the negative side. So final answer, negative infinity. A positive number divided by a negative number is definitely negative. Think about dividing by negative 1/10. You would have got negative 120. Divided by negative 100, we get negative 1200. Divided by negative 1,000,000, we get negative 12,000,000. As it gets closer and closer to 0, the number is humongous, but it's negative. It's in the negative direction. Humongous. 23, right?
The limit as y approaches 6 of y plus 6 over y squared minus 36
And what do we say?
equals.
Okay?
over 0. Does not
Okay. Now, in this case, the 0 could be plus or minus. Maybe that's, I've never done that before, but maybe that's the way to think about it. Then 0 could be positive or negative because it depends. I think this is the question you were asking, or it could have been. It depends on whether we're from the left or from the right, as to whether this is positive or negative. So Maddie said it doesn't exist. That's correct. Okay. Okay, 22, 23, 24. Doing great here. Okay, Henry.
The limit as x approaches 4 from the right of 3 minus x all over x squared minus 2x minus 8.
2x minus what?
8.
Okay, what do we get on top?
-1.
What do we get on bottom?
0.
0. Is it a positive 0 or negative 0? I would say I'm not sure. We need to come back and factor this. We know that there's an x minus 4 factor because we're getting 0. Now, Henry plugged in, he gets 16 minus 8 minus 9 under 8 is 0. But it's hard to tell if it's positive 0 or negative 0 for me. It's hard to tell. Okay? So, it might not be. Do you know what it is? Can you do it by looking at it? You think it's positive or negative?
Negative.
Okay, let's see if that's true. When we change this into x minus 4, x plus 2, now we can say -1 over, is this positive or negative 0 here?
Positive.
And is this, what's this? 6. So you were wrong. Okay, you were wrong. And that's my point. It's really difficult to look at this and know whether it's coming from the positive side or negative side. Well, when you look at this, you're not going to mess up. Did I factor it correctly? 3 minus x is 3 minus x. I didn't mess that up. It's the same. X squared minus 2x minus x. XX, 4 and 2, so it's x squared plus 2x. It's correct. When you plug in something a little bigger than 4, this is -1. This is a positive 0. That's positive. So what's the final answer here, Henry? Final answer.
Negative infinity.
Negative infinity. The 0 is dominating on the bottom, creating an infinitely large answer. Beyond any number you can imagine, it gets there. But it's got to be negative. Okay? Please speak up. Follow-up questions. Please speak up. Okay, I think we're doing really well with this. Alois, 25.
The limit as x approaches 4 from the negative side of 3 minus x of all over x squared minus 2x minus 8.
Okay, we really have the same problem as above, don't we? So let's factor it the same way, because it didn't change. Let's see if I can make it legible. So I'm still taking the limit as x approaches 4 from the left. And like I had these 3 numbers here, Alois, give me the 3 numbers here.
-1, and then -0, and 6.
Final answer?
Positive.
Yes. No need to ask. You knew it was positive infinity. A negative divided by a negative times a positive or divided by a positive, whatever you want. Yeah, 2 negatives. 2 negatives makes a positive answer. Positive infinity. 27. Chin.
The limit as x approaches to 2 from the right of 1 over f to the value of 2 minus 1. 2 minus x, sorry.
Okay, sort of hard here because when we plug it in, we get 1 over 0. So we're thinking infinity, negative infinity does not exist. When it's one-sided, it's probably going to be one of these two. When it's two-sided, be careful. You're going to have to check both sides and see if they were the same. Okay? So in this case, if I have a number a little bit bigger than 2, then this ends up being negative in here. Well, we're taking the absolute value of it, so it's becoming positive, right? So this is positive infinity. H 28.
Okay. The limit as x approaches to 3 from the left of 1 over the absolute value x minus 3.
Okay, so this is a similar problem. 3 to the left, 1 over x minus 3. What do you think?
So if we plug 3, it gets to 0. So it's,
Is it going to be positive or is it going to be negative? It's got to be positive. Look, this is an absolute value thing. It's always positive. This is absolute value. It's always positive. It has no choice to be positive. So answer, positive infinity. Is 29 the same thing or is it different? Different. So I thought, I didn't remember from last year, but I thought the next question was going to be 2 from the left. And what would the answer been for 2 to the left of this? Same thing. So what would have been if they just said 2? The limit as x approaches 2 of that. Positive infinity. Again, the limit's not existing when we get positive or negative infinity, but we're giving more information when we say positive infinity. Okay? Great job. Matt, 29.
The limit as x approaches 9 of x minus 9 all over root of x minus 3.
And we plug it in, what do we get?
0 over 0.
So we have to do some factoring or some algebraic manipulation. We jump back to the first type of problem, but it's a little harder. We have this root x minus 3 here. It's making it harder. Okay? So we jump back, and we have 2 choices.
Can you take root x minus 3 x plus 3 at the top?
Yes, that's going to be the trick. Okay? That's one good way, is to write this as root x plus 3, root x minus 3. Now those cancel, and what's the answer? Because that all cancel, we plug the 9 into that, and what do we get?
6.
Correct. Root 9, 3 plus 3. Jumping into finance is great there. Okay. Hey, we this is impressive. We're going to get them all done. 31. You know it?
Okay, it's a piecewise function,
Okay.
and so f of x equals x minus 1 when x is less than or equal to 3, and then 3x minus 7 when x is greater than 3. And it says find the limit as x approaches 3 from the left of f of x. Find the limit as x approaches 3 from the right of x, and then find the limit as x approaches 3 of x.
So they're dealing with the boundary value, which is the one of interest. There's no discontinuity in here even possible, except at the boundary, because that's a line, that's a line. Lines are continuous. But at the boundary, if we approach 3 from the left, should I be looking at the top or the bottom of the piecewise?
The top.
The top. And so we basically get 3 minus 1, we get 2. That's going to be our answer. It's a line, and the line x minus 1, when x is 3, it goes through 2, y is 2. How about this next one? We're approaching from the right.
So you would get negative 2?
3 times 3 minus 7, no, still positive 2, right?
Oh yeah, sorry.
Okay? So what's the overall limit?
2.
We got the same thing, every case, so we get 2. Now with piecewise defined, you're almost always going to be able to get a limit for the left, get a limit for the right, but then you got to find out if they're the same. If they're not the same, what do we say for the overall limit? Does not exist. Okay? Great. One more and we'll stop.
First rationalize the numerator, then find the limit. The limit as x approaches 0 of square root x plus 4 minus 2 all over x.
Okay, if we plug in 0, by the way, we're getting 0 over 0. So they said we had to do something. And we can't factor anything here, but they gave us a hint. They said rationalize the numerator. That's a bizarre idea, but we want to make the numerator so it doesn't have square roots in it. So what do?
Mean square.
No, we can't square it because when you have a fraction like 2/3, if you square top and bottom, it's not the same fraction anymore.
Okay.
We have to multiply top and bottom by the same thing, or we have to add the plus and negative the same thing.
Conjugate.
Conjugate, which is,
Square root of x plus 4 by plus 2.
and we do the same thing top and bottom. Now, we don't worry about this bottom, no big deal. But on top, let's work it out, Michael. First, do the FOIL. First,
X plus 4.
outside,
2 square root of x plus 4.
inside,
2 square root of x plus 4.
not quite.
Minus 2 square root. And 4.
So outside and inside,
Cancel.
they always do, because they're
And
conjugates.
minus 4.
Minus 4. Now, what happens on top? What happens then? We have x plus 4 minus 4.
So the 4 goes away.
So the 4's go away. And now what happens?
The x's go away.
The x's go away.
You get 1.
And so we have 1 on top. And we have root x plus 4 plus 2 on the bottom. We're taking this as x goes to 0. So knock it out. What do we get?
1/4.
Perfect. Great job. Stop the video. Great job. Okay.